Right now, as you're sitting in your chair, scrolling through your phone, or perhaps staring out a window, there is a ghost haunting the suburbs of our solar system. It is a small, cold piece of 1970s technology about the size of a compact car. It is moving through the absolute crushing void of interstellar space at 38,000 miles per hour. It hasn't seen the sun as anything more than a bright star in over a decade. It hasn't felt the warmth of a planet since the Reagan administration. This is Voyager 1. Launched on September 5th, 1977, it has been flying non-stop for nearly half a century. After covering 16 billion miles, a number so large our brains literally cannot visualize it, you might think it's out there. You might think it's finally reaching the deep cosmos, but the reality is much more humbling. In the grand scheme of the universe, Voyager 1 hasn't even left the front porch. If you pointed Voyager toward the Andromeda Galaxy, our nearest large neighbor, it would take 44 billion years to arrive. To put that in perspective, the entire universe has only existed for 13.8 billion years. Voyager would need the universe to live its entire life, die, and be reborn 3 more times just to finish the trip. Tonight, we aren't just talking about a satellite. We are talking about the furthest reach of the human spirit and the terrifying, beautiful scale of the space between us and the stars. To understand why Voyager is a miracle, you have to understand how primitive it actually is. When NASA engineers built this craft, Jimmy Carter was president. Diabo tu spintay. Just been released. Voyager's brain is a masterpiece of era-appropriate engineering, but by today's standards, it's a calculator. It processes about 8,000 instructions per second. Your modern smartphone handles roughly 14 billion. Your car's key fob, the little plastic button that unlocks your door, has more computing power than the machine currently representing humanity in interstellar space, and yet it survives. It was designed for a 4-year mission. Just fly past Jupiter, snap some photos of Saturn's rings, send the data back via radio waves, and then it was supposed to die. But the engineers built it with a certain kind of 1970s over-engineering. They powered it with 3 radioisotope thermoelectric generators, essentially lumps of decaying plutonium-238 that generate heat, which is then converted into electricity. That plutonium heart is still beating. Think about the environment it's in. It's nearly 450 degrees Fahrenheit. It's being pelted by cosmic rays. It's billions of miles from the nearest repair shop. And yet, in August of 2012, Voyager 1 did something no human-made object had ever done. It crossed the heliopause. This is the boundary where the sun's breath, the solar wind, finally loses its battle against the pressure of the galaxy. Voyager 1 left the sun's protection. It entered the interstellar medium. It is the first time our species has truly touched the deep ocean of the stars. We are currently in March 2026, and as we speak, Voyager is approaching a milestone that is both a triumph and a tragedy. When NASA wants to talk to Voyager, they send a command. That command travels at the speed of light, 300,000 kilometers per second. That is the fastest anything can move in our universe. Even at that blistering speed, it takes 23 hours and 50 minutes for our hello to reach the spacecraft, and another 24 hours for Voyager to whisper back, "I hear you." By the end of this year, Voyager 1 will officially be 1 light day from Earth. If you want to feel small, consider this. In 50 years of constant flight at $38,000 mph, we have managed to send a physical object only as far as light travels in 1 day. Now look at the stars. The nearest star system, Alpha Centauri, is 4.3 light-years away. That's over 1,500 light days. Voyager has spent half a century covering one of them. To help us grasp this, let's use a scale we can understand. If the distance from Earth to Voyager 1 were the width of a single human hair, the distance to the Andromeda Galaxy would be the length of a professional football field. We have spent 50 years traveling the width of a hair. We haven't even stepped onto the grass of the field yet. This is the great silence of the universe. It isn't just that things are far apart. It's that the void between them is so vast, it defies human logic. If you were standing on Voyager right now, looking back at Earth, the sun would be nothing more than a particularly bright dot in a sea of black. Everything you've ever known, every war, every love story, every empire is contained on a pale blue dot that Voyager can no longer even see with its cameras. If Voyager was just a machine, this would be a story of physics. But it's not just a machine. It's a message. Bolted to the side of the craft is a 12-inch gold-plated copper record. It's called the Golden Record. It is, without exaggeration, the most romantic thing humanity has ever done. In 1977, a committee led by Carl Sagan was tasked with summarizing the entire human race for an audience that might not exist for 1 billion years. They didn't just put math on there. They put 55 languages, from the ancient Sumerian of 6,000 years ago to modern Mandarin. They put the sounds of Earth, a tractor, a train, the sound of a mother kissing her child, the complex songs of humpback whales. They included music, Bach, Beethoven, and yes, Chuck Berry's Johnny B. Good. There was actually a joke at the time that if aliens found the record, their first message back would be, "Send more Chuck Berry." But there is a specific detail on that record that is deeply human. Among the data is a 1-minute recording of the brainwaves and heartbeat of a woman named Anne Druyan. At the time of the recording, Anne had just fallen deeply in love with Carl Sagan. As the sensors tracked her heart and mind, she focused her thoughts on the history of ideas, the struggle of our species, and the feeling of what it was like to be in love. Right now, 16 billion miles away, in a place so cold that atoms almost stop moving, the electrical signature of a woman falling in love is drifting through the dark. And here's the reality. The Golden Record will likely outlast humanity. In about 5 billion years, our sun will run out of fuel. It will expand into a red giant, boiling the oceans of Earth and likely consuming the planet itself. The mountains will melt. The atmosphere will blow away. Everything we have built will be gone, but Voyager 1 will still be out there. Long after the Earth is a cinder, that gold disk will be carrying our music, our languages, and Anne's heartbeat through the stars. It is our only shot at immortality. While Voyager drifts, the universe around it is also in motion. We've always been told that our galaxy and Andromeda are on a collision course, two giants destined to smash into each other at 250,000 miles per hour. But as of 2026, the story has changed. A groundbreaking study recently analyzed data from the Gaia Observatory and the Hubble Space Telescope. By running 100,000 simulations, scientists found that a collision is no longer a certainty. There's only about a 50% chance the Milky Way and Andromeda will actually hit in the next 10 billion years. Why? Because of the little guys. Smaller galaxies like the Large Magellanic Cloud are tugging on us, acting like cosmic anchors that might pull us just enough off course to miss Andromeda entirely. But even if we did collide, Voyager would be safe. Space is so empty that even when two galaxies crash, the stars themselves almost never hit each other. It's like two swarms of bees passing through one another. The bees are so small and the gaps are so large that they just fly right past. For Voyager, the Great Collision would be nothing more than a slow change in the scenery. It is on its own path, unbothered by the fate of empires or the collision of galaxies. So, Why does this matter? Why do we care about a dying probe and a 44 billion year journey we will never see the end of? We care because the number 44 billion isn't just a distance, it's a mirror. It shows us exactly where we stand. It tells us that the universe is vast beyond our comprehension, but it also tells us that we are a species that refuses to stay in its cradle. We knew Voyager would never reach another star in any human lifetime. We knew the record would probably never be found, and we did it anyway. We etched our music into gold and threw it into the infinite ocean. That is not an act of futility. It is the ultimate act of faith. The same physics that makes the stars so far away is the same physics that forged the iron in your blood inside the heart of an exploding star billions of years ago. You are not just in the universe, you are a part of it trying to understand itself. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a star called Gliese 445. It won't stop there. It will keep going, past stars that haven't been born yet, through a cosmos that is still expanding. Long after you and I are gone, and long after the last person who remembers our names has passed, Voyager will be there, a small, silent ambassador from a blue planet that once dared to wonder what was out there. If you've stayed with me this far, you are part of the small percentage of people who actually care about the why and the how of our existence. If you found this journey valuable, please hit the subscribe button and turn on notifications. We go deep into these stories every week because the surface level just isn't enough. Drop a comment below. If you could put one sound or one image on a new golden record today in 2026, what would it be? I read every single one. Until next time, keep looking up, because the void isn't just empty space, it's full of stories.